Hi, and welcome to the eBPF and Cilium Office Hours live stream. This is episode 168, and I'm Liz Rice, and I am from Isovalent, now part of Cisco, where we do loads of exciting things with eBPF and Cilium. And another place where lots of exciting things are going to be happening related to Cilium and eBPF is the upcoming KubeCon in London. So the main news for this week really is that the schedules are live for both the main KubeCon conference, which is happening on the 2nd to the 4th of April. And also, hot off the press, the schedules have been released for the co-located events, including CiliumCon. So there's lots of, let me have a quick filter of this to show you lots of eBPF related content and people, some friendly faces here, list of people who have eBPF in their listings, and some pretty interesting sessions coming up that are going to be talking about eBPF during KubeCon. And then in addition, we have a half-day event on the morning of 1st of April. It's not going to be an April Fool's, I promise. And that's going to be all about Cilium, basically. So I hope we're going to see lots of you there. As always, if you're watching, do say hello. It's really nice to hear that people are watching. And I've had a first hello here from Joseph. So hi to Joseph in Paris. So if you're going to be attending CiliumCon, definitely make sure to come by and say hello and let us know in the comments as well. All right. I think that is pretty much all the preamble. So I think it's time to get on with the main business of the day. We're going to be talking about BPF tokens. And so I'd like to welcome to eCHO Dave Tucker, frequent flyer on this live stream, I think, Dave.
Yeah, was this like the third time now, maybe?
Could be. Yes. Yeah. Well, pleasure to have you again. So thank you for joining us.
Yes, thanks for having me.
So I guess the last time we met in person was actually at the last KubeCon, where we had a bit of a conversation about BPF tokens, today's topic, and how you've been looking at them in the context of a project called BPF Man. So before we go too far, I'll say hello to... I'm not going to try to say that because I think I will pronounce your name wrong, but greetings to you in Germany. Yeah, so BPF tokens. Let's start by, what even are BPF tokens?
Yeah, that's a really good place to start. So we start our journey with Kent BPF. So the kernel privilege that allows you to interact with the BPF subsystem. So way back along, there were two ways of using eBPF. You could have unprivileged BPF, where everybody could do stuff, and that was bad for lots of reasons. It quickly got disabled in every Linux distro ever, because once you have the ability to load BPF programs, you've got effective root on the system. Even if you're not trying to do something nefarious like compromise the system or privilege escalation, you can still do a lot of damage. So cat BPF exists to constrain which users on the system can do what with BPF.
I feel like a lot of the time when I'm perhaps giving a presentation about what eBPF is, one of the main questions that comes up is like, isn't this like really dangerous? And if it's this powerful, how do you stop people from doing bad things with it? And essentially cat BPF is one of the answers to that question.
Yeah, and what's quite funny as well is that depending which space that you sit in, so in the like enterprise Kubernetes space, it's quite often that you see people talk about all the amazing stuff that you can do with BPF. If you switch though into the security thing and you go to like a DEF CON or something, it's look at all these ways that we were able to compromise the system using eBPF. It's a very different, it's an incredibly powerful tool, and you can use it for good or you can use it for evil. But yes, we can constrain who can do what to a degree with cat BPF, but it's a big hammer, right? It says you can BPF, it doesn't say you can just load XDP programs on this interface. It says you can BPF all the things. So coming from a place of security and least privilege, what would be really nice is if a mechanism existed where we could grant a more fine-grained capability around who can do precisely what with cat BPF, and that's where BPF tokens came from. I can't take any credit for this at all because it's not my work. So I'm representing the work of Andrew from Meta, who really spearheaded this inside the kernel. But what BPF token allows you to do is it does give you that sort of fine-grained control over what parts of the BPF subsystem you can interact with without requiring cat BPF. And it's designed to be used in conjunction with user namespaces, which are another neat kernel feature that allows you to avoid having, an effective root inside a namespace. You can kind of remap that to an unprivileged user ID on the host, so that you may look like root inside the user namespace, but in reality, the kernel doesn't believe that you're root and doesn't grant you all of these superpowers to do whatever you like with the kernel.
Yeah, I know sort of really in the early days of thinking about security on containers and security for Kubernetes, one of the big sort of shoot yourself in the foot things you can do is, oh, I think I'm root inside this container, and not realize that unless you're using user namespaces, that root inside the container is root on the host. And user namespaces, I would say, were a relatively kind of newer addition to the set of namespaces, because people realize this is actually a problem. People are treating these containers as if they're kind of like VMs, but they've got root privileges on the host, and they don't necessarily realize that. So I think user namespaces is at least an attempt to make it much harder for people to have those host root privileges.
Yes.
But you've got to use them, right? You've got to have user namespaces turned on before they're going to be of any benefit at all. And whether people are actually using them is a bit more questionable.
Right. So this is the constant issue that we have with all things security, is that on one side you have security, and on the other side you have usability. And where with containers, as it were before in the good old days of Docker, where we used or Podman or choose container runtime of choice. Let's be fair. You can have certain namespaces to restrict things like networking or mounts and other things, and those are all good. We still want to be able to do fun stuff with containers, and with fun stuff, I mean you might want to shove in a device like a GPU. That would be cool. Or you might want to put in a SRIAV network interface. Well, bind mount a file, or like something pretty pedestrian like that, bind mount a directory. And that becomes very difficult when you use user namespaces, which are much more of a secure enclave, if you like. Everything is tightly locked down and controlled, and having the ability to bring in some of those outside things to the inside is not so possible anymore, either because it's hard, because the interface doesn't exist in the kernel to kind of move those across, or you just literally don't have the privileges inside of the user namespace to actually make the most of those devices, which I think is why we've kind of seen a slower adoption of user namespaces inside of things like Kubernetes, and just for that reason alone.
And I think there's always just a kind of a bit of friction to even looking into it. So even if you're just running like a very vanilla, I don't know, web microservice, unless you've got a good reason to do it, you're probably not going to experiment with trying it in a user namespace or in a rootless container. So yeah, go out there, folks, and try running your containers in user namespaces in rootless containers, and let us know how you get on.
Yeah, please do. Honestly, like I used to know this stuff a lot better than I did.
Yeah.
But I remember there were problems. I would love very much for somebody in the audience to say, "Hey, all the problems are solved. Everything is grand." But at least, as far as I understand it, those problems are not solved problems, and it means that therefore user namespaces aren't used for everybody. which makes me incredibly upset, because me as the cat BPF or like BPF man, a person that wants to try and manage better who can do what with cat BPF, for containers and for Kubernetes in general, those controls don't exist. So what I want is I want BPF tokens, but I want it to be more generally applicable. I want it to apply to, you know, a random process on the host or a container, and not necessarily be tied to having or require you to be in a user namespace.
Right. Yes. So let's just talk. I had a little look at the BPF token documentation, which there's some great docs that have been added over the last, I don't know, year or so, that you can get to from ebpf.io. And there's a lot of stuff that, you know, a year or two ago wasn't documented, has started to get a bit more information out there, which I think is fantastic. So shout out to, I know Dylan is one of the people who's been involved in that, but I'm sure there are many others as well. So everybody who's been contributing to those docs, good on you. And when I looked at those docs, they talked a little bit about BPF tokens. There is a page there. I've linked to it in the show notes as well. And it talks about how the idea of these BPF tokens is that a privileged process can delegate permission to an unprivileged process, i.e. a user namespace, a process in a user namespace that doesn't have root privileges or doesn't have cat BPF. And this token will allow that unprivileged process to make BPF system calls. Is that more or less right?
Yeah, more or less. There's always, with these things, this nuance. So I actually implemented BPF token support inside of Aya, which is our Rust eBPF library. So it would be equivalent to the Cilium BPF Go library. And I had expected it to work a certain way after reading the documentation, and it didn't work. So I sent an email to the mailing list, and they said, "Oh, you know, take a look at the self tests." And it turned out that one of the big pieces of nuance here is that in order for the token to actually appear, there is you can't do what I wanted to do, which was like create a BPF file system and then just shove it inside a user namespace, and everything would be grand. You have to create the BPF file system.
Can I just rewind a little bit on that, just to sort of dive into that? So I guess the idea of having that BPF file system, would it be you'd expect to have perhaps one BPF file system per user namespace, so that processes in that namespace can access BPF programs that are pinned into that file system, and only those?
Yeah, so BPF file systems are awesome. They're, you know, a general container for all BPF objects that we can pin off to that file system and access them later. And already in BPF Man, we already have that model where we give you a BPF file system dedicated to your specific application. That means you can just read your stuff and you can't read other people's stuff. And the way that the deployment works with user namespaces is similar. But where BPF Man provisions a user namespace and then passes that into the container through a bind mount, that's not the way it's supposed to work with user namespaces. The BPF file system gets created inside the user namespace, and then the file descriptor gets passed back over into a privileged process over here in the init namespace that says, you're this process over here. I know that these are the permissions that you're supposed to have, so I'll put these as mount options on your little mount. Here you go, have your file descriptor back, and then it gets finalized and created into a BPF file system over here. So in effect, that means there is no token. There isn't a token that gets passed from this initial namespace with some privileges attached to it, like a JSON web token or something similar. You know, you don't have an actual physical thing that's been signed that says, you know, this process can do this thing. It's literally by merit of the file system itself and having flags on there that within the namespace, you can make a system call to say, hey, give me a token. And then you can just use that file descriptor later in your BPF syscalls. And that kind of overrides the permission checks. So it's kind of weird because we talk about them as being tokens, but it's kind of like more a special file descriptor on a BPF file system than it is like a tangible token thing that you could pass around, I suppose.
So does that mean that in this system, an unprivileged process wouldn't be loading and unloading programs itself or attaching programs itself? It would be relying on the privileged process to do that on its behalf?
Nope,
No?
it does it all by itself. So once it's got its BPF file system and it's issued its token create system call and it gets its BPF token for all of the syscalls that do dangerous things like creating programs or creating maps, you can then just use your token with that overrides the cat BPF permission check. So
okay, so you do actually have a token in your hand in the unprivileged process.
It just doesn't kind of get passed to you from this side to the other. It's kind of like this side says, yeah, token's going to be shaped like this, and then you kind of pick it up over the other side somehow. I don't know, mentally, it didn't make sense to me when I implemented it, and I'm sure that, maybe I'm looking at it wrong or it's just me, but at least it took me a little while to get my head around the model and the way that worked. When thinking about like, how do I do this, and then how do I kind of take this idea and extend it and make it work for everything? Because that's obviously my stake in all of this is to make it work for containers and for random processes on the host that aren't namespaces.
Yeah. You've mentioned BPF Man a couple of times, so maybe just let's hear about what BPF Man is.
Oh yeah, sure. So I looked the other day and I realized that actually how old it is. I mean, I'm so used to saying, oh, we did it like a year ago, but the reality is it's nearly 3 years old, which is kind of scary, I suppose. But the idea behind BPF Man was we wanted to change up some of the way that we were deploying BPF programs in a way to make them sort of cloud native and secure, like two things which, I think super important. So for the cloud native aspect, what we do is we package all of your eBPF programs inside containers. And because they're packaged inside containers, we get to do fun stuff like signing the containers. So there is no signing for BPF, so we can sign the containers. BPF Man can then pull a container from a registry. We can check signatures, make sure that it is allowed to be by policy allowed to be run on that machine, etc., which is pretty cool. And for the security side, we made a deliberate decision to split who loads BPF programs from who interacts with them. So BPF Man, the privileged thing, gets to load the BPF programs. It will then give the unprivileged process, so your container running on the host, which doesn't need cat BPF anymore. It gives you a file system, and through that BPF file system, you can do all of the, you can read maps, you can write to maps, you can do that type of operation without requiring a privilege. So that's what BPF Man is in a nutshell.
Okay, so the unprivileged program would get to interact with programs through maps. Does it also get to load and unload programs, or does it need to go to BPF Man to do that?
It goes to BPF Man to do that. And because we're cloud native, everything happens through custom resources in Kubernetes. So we have a BPF application custom resource where we say, you describe your BPF application. So you would say, I don't know, I've got an XDP program, and this XDP program needs to be attached over here, and I've got a TCX program that needs to be attached over here, and this K probe and that and everything else. And what BPF Man will do is it will say, okay, cool, I'll load all of these into the kernel and attach them. And then when your user space application or your pod that, or deployment or whatever you call it that wants to be reading those maps is going to get scheduled, you give it some annotations to say, I'm the user space portion of this BPF application that I asked to be deployed earlier. And then all of those map pins will manifest inside that container through the magic of a BPF file system. And you'll be able to kind of do whatever it is. So if you're a metrics program, you can read back from those maps and do your open telemetry stuff or whatever it is that you want to do. And you don't need cat BPF on that pod anymore because we're doing operations that by design are totally fine to do without privileges.
Okay. All right. So does And would I be right in saying that BPF Man doesn't rely on these user namespaces? That's kind of orthogonal to the BPF token.
Yes. So I guess the way that we came to tokens was when I showed up in the community, eBPF community, and said, hey, I've got this really good idea. We should separate the loading of the programs from like the everyday like interaction with the maps and stuff, because this bit is super duper privileged and we probably don't want to have stuff with cat BPF be long running, because it's a really tasty target for somebody to break into and then get that cat BPF, which you don't want. I was told, and rightly so by a lot of people, that there are many use cases where you do need very fine-grained control over the way that you load programs. One of those examples is Cilium, where you're compiling programs on the fly for network policy and stuff, which is like great, but it means that you can't do that split between this thing is doing the load and then these pins are going over here to go and do whatever for reading in the user space side. Similarly, when we tried to take some other users of eBPF and kind of convert what they were doing over to working with BPF Man, it was supposed to be seamless. It was supposed to be like, hey, just a couple of lines code change. But then we very quickly realized that, yeah, okay, that's not exactly paying off. So it planted the seed for, wouldn't it be great if we could have all of the advantages that BPF Man was doing for you, so all the cloud native stuff and everything else, but kind of like allow you to selectively use cat BPF to load whatever, so that we could, rather than granting you cat BPF and letting you keep it forever, we could say, all right, you can have cat BPF, you can load your own stuff, you can be the master of your own destiny, but you need to follow by the rules, and the rules are very fine-grained. So like given the example of Cilium, we would say like, yes, you are Cilium. We've verified that you are Cilium, and you've told us that you only need to use like this much of the BPF subsystem to load these specific programs and attach to these specific places. So we're going to police you to make sure that those are the only operations that you can do. Because, if you were to get compromised, which is not impossible, we'd at least be able to be sure that you're only able to use that much of the BPF subsystem. So selfishly for us, it's a way of getting more people to use BPF Man, because you don't need to change anything anymore. So that cost of adoption is reduced. And it also, by extension, would make BPF more secure inside of Kubernetes. So that's how we came into this token thing, was thinking, hey, it's in the kernel, we can use it, it's going to be great. And then we tried using it and it wasn't so great. So that's when we started thinking about how we could achieve something similar. And I think we're close, maybe. I guess it's not an easy thing to do. I really like, so no shade on BPF tokens, great idea, works great in user namespaces, but as we said before, we're not using those. I do, however, like the API that tokens offers and how fine-grained it is. So you can say, I will let you make a BPF create program map call for this specific map type. We can kind of get that level of granularity there. So what our plan is at the moment is to have a program give you a manifest of the things that it's going to do. And that can happen through Kubernetes YAML or annotations. We're not sure what the interface is going to look like, but that would be BPF Man's stake in the ground is you tell us what it is that you want to do. And then to police that, we would use another cool BPF feature, which is the LSM program type, which is a Linux security module. We would just install an LSM program that would then essentially bound your process to those rules that you've already described ahead of time. And that should give us effectively the same thing. And if we're smart about the way that we design the API, which I'm keen on doing, it would mean that hopefully those two approaches would be compatible. So the way that you describe your program for use in Kubernetes or whatever would be the same way that you describe the constraints your program would have inside a user namespace. So if you decide later down the line that actually you want to do the whole token thing, then that's great. It just happens to work both ways without you having to change things.
That makes sense. Yeah. I also have some recollection that BPF Man was going to help with, or is going to help with, the order in which BPF programs might be attached to the same point. What's happening with that?
Yeah, so we still do that.
Okay.
Again, standing on the shoulders of giants, as always. So the XDP subsystem maintainers, so Jesper and Toki, they created a protocol, effectively, that allows you to share an XDP hook, which is exclusive. So usually, first program attached wins, and that's it. But they designed a cooperative means of linking all of these programs together. And that's something that we use inside BPF Man to offer that same type of capability. We've then taken that and used the same approach to do that program sharing, but for TC programs. And this predates all the work that Daniel and others did on TCX, which is the new, more extensible TC hook, where you don't have issues with who owns the Q disk, which is a problem solved by BPF Man, because BPF Man owns the Q disk. But when you didn't have a tiebreaker of who owned it, you'd end up with problems, and somebody trying to delete it and somebody trying to recreate it and reattach, and it kind of all got messy. So yes, very long way of answering your question, but we do absolutely help with that ordering of programs.
Yeah, cool. We got a question in from Ron. Let's see if we can figure this out together. So, how can eBPF tokens, and my suspicion is that the word tokens here might not be quite what we want to answer. How can eBPF tokens enhance real-time digital marketing analytics tracking with minimal computational overhead? I think there's quite a lot of words to unpack in that question.
Yeah, unfortunately, the only two that I understand are eBPF tokens. So it's I don't know enough about the use case to tell you how it would help. I think the reality is it wouldn't. Tokens are a mechanism to constrain what the program can do. So assuming you're doing digital marketing analytics or something like that, it may be a regulated market where you have to say, look, our stuff is immune to compromise, or these are the ways in which we're securing our system to make sure customer data doesn't get leaked or whatever. And being able to say that, hey, we're using eBPF and it's great, but that eBPF is constrained so that we can only do these certain operations in there, is certainly a better means of saying that you're compliant with regulations than just saying my thing uses eBPF and all bets are off. That's a common theme that we see from customers that I talk to that are using eBPF, is that you have developers that are like, man, we can use eBPF for everything. We can trace all of these things, even operations now. Like, give me BPF trace everywhere. And the security team are just like, absolutely not. There is no way. You are banned. There is no eBPF on this infrastructure at all, because we want to disable it. And my hope is that work around tokens and constraining who can do what cat BPF will absolutely help increase adoption in those markets, and at least ease concerns from security teams across the enterprises.
Yeah, absolutely. And I think the other sort of half of this question is about, well, the minimal computational overhead that you get by using eBPF to track stuff. And I guess the question there is whether or not the analytics that we're talking about here are analytics that are kind of being generated within the kernel or generated within user space. Because if they're being generated in the kernel, then absolutely eBPF can help you measure stuff incredibly performant, with incredible performance and very low overhead. Whereas if we're talking about measuring stuff that's happening in user space, eBPF might not be the right hammer for that nail. Yeah, depending on what it is you're measuring. Yeah.
It's a tricky one. If it were like a cookie in an HTTP packet, for example, or something in an HTTP header that you wanted to pull out, you could do that in eBPF pretty quickly.
That's true.
With minimal overhead, that's absolutely doable. But as with all things, like, yes, you can use eBPF for everything, but the question is, do you really need to use eBPF for it? Is there no other means under which you could get this information?
Or is there no other means that is as efficient, or at least as efficient? And sometimes just the sheer complexity of writing the eBPF code to do the thing may outweigh the benefit of the performance gain you'd get. There's so many variables.
Oh yeah.
All right. So, I mean, it sounds like there is plenty of work afoot in the world of BPF, man. What's the kind of future hold, do you think?
Yeah, that is the big question. So BPF Man, obviously I work at Red Hat. We're planning on using this inside of OpenShift. It's kind of headed out into a developer preview, and we'll be bringing that through hopefully to be generally available soon. But as a result of that, I've got a whole lot of work to do around just making it more stable, fixing bugs, that type of thing. However, that said, this token thing is really important to me. So I really, really want to try and get this implemented for KubeCon. I'm planning to be there, and I believe that BPF Man is going to have a booth in the project pavilion. So I'm hopeful, fingers crossed, that I'll have a demo that I can show people there of how we're able to kind of use tokens to constrain programs deployed into Kubernetes. Fingers crossed, right?
That will be great. And if you do, we'll do another echo and you can show the demo.
Yeah, that would be awesome. Apologies. I really wish I'd brought some diagrams and had a demo ready for today, but it's been a busy start to the year. So
absolutely, yeah. No, that's totally fair enough. Well, unless there's anything that we've missed that you would like to ask, I will just mention to the audience, if you've got any questions, type them in quickly.
So I'm gone after that.
I think this has been really, useful and interesting, certainly for me, to understand a bit more about the status of what's happening with the BPF tokens. And so thank you for that. Thank you for spending your Friday afternoon with us here on eCHO. And I'm sure we'll catch up in London at KubeCon, and hopefully we'll see lots of the audience there as well. So unless there's anything else you wanted to add at the last minute,
I will just say, BPF Man is something I've been involved with for a few years now. It is, however, a open source project, and it is a CNCF sandbox project as well. So we're fully open to collaboration. If you think I'm doing something wrong, tell me. If you think that we could be doing something better, I want to hear about that as well. I'm certainly, open to any and all feedback. So you can find me on the Kubernetes Slack. There's a BPF Man channel. You can find me on the Cilium Slack. I mean, I'm around. So please just feel free to reach out if you have any questions.
Fantastic. And there is a link in the show notes, I think, to BPF Man, so people can follow that to check out the project more and potentially get involved. Yeah. Fabulous. So thanks everyone for joining us this afternoon. Oh, there's a quick comment from Paul saying interesting stuff. So thank you, Dave. And we'll catch up again after KubeCon. And to everyone at home, have a wonderful weekend, and we'll see you in the future on eCHO.